Hi there and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson we'll be learning about the halogens or elements found in group 7 in the periodic table. This is for GCSE chemistry, and if you find this video helpful, feel free to like, comment and subscribe and share this with someone you think would also benefit from watching it. The question of the day is it really in swimming pools? And the it we're talking about is chlorine. And the answer is yes, we do add chlorine to swimming pools, specifically because chlorine acts as an antiseptic to sterilize the water and actually prevent any microorganisms that may cause disease or pathogens from developing and causing harm to the human body. So, chlorine has a very useful, um, advantageous function for us, but chlorine is also what we consider a halogen, and this is specifically linked to the GCSE course. So, halogens are all non-metals. They're found on the right-hand side of the periodic table, and because they're in group 7, they all have 7 electrons in their outer shell. Specific elements we're talking about include fluorine, chlorine, bromine, iodine, astenine, and tennessine. But at GCSE, you need to focus on the first four specifically, and they do like you to know about the properties of these elements. So, because they are in group 7, they all have the ability to form diatomic molecules. So, two atoms of fluorine, for example, will chemically bond together and form a covalent bond to become that diatomic molecule. They also can react with other substances, say metals and non-metals as well, and we'll talk about that today. They also have an increasing melting and boiling point as we go down the group. And this is because as the atomic radius increases, the molecules require more energy to be broken apart because of the forces, intermolecular forces that are occurring there. So the reactivity is very much linked to the number of electrons that are found in the atomic shell, the outer electron shell. Because there are 7 electrons there, the chemical properties are going to be similar. So, like I said, the melting and boiling points will all increase as we go down the group. However, the reactivity of these elements actually decreases. And this is directly opposite than elements in group 1. And if you want to learn more about group 1 elements, check out my video. I'll link it in the cards. And the reason that the reactivity in the halogens decreases as we go down the group is because of the atomic radius increasing. As we go down the group, there are more shells of electrons and more distance essentially between the nucleus, which is positive, and the outer electron, which is negative. And because of that distance, the force of attraction between the nucleus and the electron decreases, which means it's harder for the atom to gain another electron in its outer shell from another atom because those forces of attraction are actually weaker. Now, at GCSE, you could be asked to predict trends. So, I've got some examples here. So, the melting point, like I said, it increases as we go down the group. I've made my prediction here. So, we've got some data, say, about fluorine, chlorine, and bromine. We can predict what iodine would be based on the data given. We know that the melting point increases as we go down the group. Iodine is a much larger atom than the other atoms there, so we can draw on the bar chart. You could also be asked to write a number. That is also another way they could ask you in the exam. Have a go at the question for boiling point. Do you think iodine will have a larger boiling point or a smaller boiling point? What do you think the answer will be? Put your comments in the comment box below. So, the reactivity at GCSE you need to be aware of is the reactivity between halogens and metals. So, you can observe this by reacting the halogen with an iron wool substance. So, you get some iron wool, it's essentially just pieces of iron spun very thinly. Place that in a test tube, and we can heat up that substance using a Bunsen burner. And we can observe what happens. And what will happen is the halogen will react with the metal to form a halide salt. So, fluorine is the most reactive and it will have a very vigorous reaction, and iron fluoride will form. Chlorine is less reactive, it reacts quite quickly still, and iron chloride will form. Bromine reacts steadily, iron bromide will form, and iodine will have a slower reaction, or the slowest out of the four, and iron iodide will form. Now, notice the key bit here is the suffix of the words. Notice that fluorine, when it reacts, will form a fluoride salt, so iron fluoride. A lot of the time, students will mistake this and write iron fluorine. that wouldn't get you the mark in the exam. You have to be very careful. You can see the same is said for chlorine. Chlorine forms chloride, bromine forms bromide, iodine forms iodide. So it's really important to be aware of the suffixes, specifically when naming salts. So when halogens react with the metals, this is what is actually going on at a atomic level. So the halogens react with the metals to form the salts and can be dissolved in water to form a colorless liquid. So the halogen itself will actually accept the electron, and the metal ion will donate the electron. And this is because of the ionic bonding that's occurring. Remember, both of those atoms want to become stable, and this is why they're doing this. So you can see that sodium, which is the metal, will donate the electron to chlorine, which is the non-metal, and they'll both form ionic substances, so ions. So chlorine now has a negative charge because it's gained an electron, whereas sodium has a positive charge because it has lost that electron, it's donated it. And you can see that their atomic structures, you can see that they're now both stable, all their shells are full. So we can also look at halogens reacting with nonmetals. So halogens, when they react with nonmetals, they form covalent bonds. And this is because of the shared electron pairs that occur in covalent bonding. And I will have a video on my channel about the different types of bonding you need to know for GCSE. But an example we have is chlorine, which is the halogen we're talking about. And we also have the non metal, which is hydrogen in this case. So we can see that hydrogen chloride will, hydrochloric acid even, will form. And this is because there is that shared pair of electrons, and both of those atoms will actually form that covalent compound and now are both stable as well. So, the last bit of the puzzle, if you will, is this idea of displacement reactions of halogens. And sometimes students confuse what the word displacement means. So, just to clarify, displacement is the ability to swap something for something else. And this is all to do with the reactivity of the halogens. So, this is why we need to know about the different trends and which one is more reactive than which other one, because we then need to actually predict the products that form. So we know as we go down the group, we decrease the reactivity. Okay. So the more reactive halogen has the power or the ability to actually take the place of a less reactive halogen or displace it and swap it out. And the reason it does that is because they're kind of in competition with each other. They want to be stable. And if it has the opportunity to do so, it will. So let's give an example then. We've got chlorine, which is the halogen, and it reacts with sodium bromide. Sodium bromide, sodium is a metal, sodium bromide is a salt. Okay. So the chlorine is more reactive than bromine. Okay. Because it's higher up on the periodic table. That means that sodium will react to actually form sodium chloride instead. So the chlorine has pushed out the bromine, and we now have sodium chloride and bromine on its own. Now, there's another example here. Have a go at it. What do you think? If fluorine reacts with potassium iodide, what do we think the products will be? Which one, as a clue, which one, iodine or fluorine, which one is more reactive? And therefore, will this fluorine displace the iodine? Answer below. I'd love to hear from you. And those of you who are doing triple science or higher combined science, you definitely will be aware of something called a redox reaction and displacement. And just to kind of finish this lesson on a little bit of that, it's kind of a nice link. So I thought I'd include it. Halogen displacement reactions are examples of redox reactions because the halogen itself will gain an electron and the halide ions will actually lose electrons. So remember, redox reactions are all about reduction. Reduction is gain of electrons, and oxidation. Oxidation is the loss or oil rig, you might remember from lessons. So, an example would be bromine reacting with sodium iodide to form iodine and sodium bromide. You can see there's been a displacement. Bromine is much more reactive than iodine, and therefore we get that displacement. However, if we actually write the ionic formula or the ionic equation, we can see that bromine, because it's more reactive, has actually been reduced. It's gained those electrons from the sodium. And the iodine, because it has been displaced, it actually loses electrons and it has therefore been oxidized. So, remember in ionic equations, you need to remove the spectator ions, the part of the equation that doesn't actually get involved. So the sodium is a spectator ion in this case. That's a whole nother video I can do. If you would like more on ionic equations, more than happy to do that. Just comment below, let me know. Also redox as well, if that's something you're interested in, more than happy to help with that. But for now, I've been the GCSE science teacher and you have been curious. Thank you so much for watching. If that was helpful, feel free to comment below, subscribe, and share with anyone you think would also benefit. If you want more help in the meantime for GCSE chemistry, biology, and physics, check out my channel. Also, I'm on Instagram and TikTok at the GCSE science teacher. Thanks so much. Take care. Bye.